Okay, let's see if this is going to be a useful way of doing books. Okay, so this is a short video to do a pupil examination quiz. So let's open up the pupil examination book. And we're going to go to the quiz chapter, so we're going to go to chapter 4. Okay, so let's have a look at this one. Switch off the lights and switch them on again. Pupil sizes are the same with the lights on and off, so there's no anisocoria. And then with the lights off, let's see the pupil reactions. No reaction. Reacts. No reaction. Reacts. I'm going to look at this side as I shine the light over here. So neither side reacts when the light is shone on this side, but both eyes react when the light is shone on that side. So as we face the patient, there's a problem on this left hand side. Now I'm going to do a swinging light test. And as the light goes across to the patient's left eye, the right eye as we're looking at it, the pupils dilate. And if we look, it's actually both pupils dilating. Okay, so what's going on here? So the first question is, are the pupils normal or abnormal? Well, they're abnormal. Next question is there anisocoria in light or dark? So no, because the pupils are the same size with the lights on and the lights off. Pupils remain the same size. Next question is, does each pupil react to light? Well, no, because the left eye doesn't react to light. The patient's on the right hand side, the patient's left eye. Is there an RAPD? Well, sort of, because when we do the swinging light test, it does dilate as you move to that left side, but it's actually not an RAPD because there is no reaction to it. If we oh sorry, let's switch that off. Because there's no reaction to direct light, this is not a relative afferent pupil defect. It's a complete afferent pupil defect on this side, on the left hand side, the patient's left side. The final question is, what would you expect the patient's vision to be in the affected eye? Well, if there's a complete afferent defect, that suggests that there's no message coming into the eye when the light is shone at the eye. So it's quite likely that there will be poor vision or no vision in the left eye. So, and there's the answer section. So we've just got an illustration of what an afferent defect might look like. So let's just quickly look here. So if we have the signal coming in, this is looking from below at the brain with the optic nerves. Now if we're looking from below, this is the patient's left eye, so this is the opposite side from the patient we just examined. But the patient's right eye, if the optic nerve is been cut or injured, then the signal doesn't go through. Whereas on the patient's left eye, the signal goes through and we get the pupil reactions. And the reactions are on both sides. So we can see how that efferent pathway comes from both sides. Just trying to see where I've got the efferent pathway. So here we can see how if the signal's coming in, normally it comes into one eye and then at the chiasm it divides and then it goes back out through the third nerves. So both eyes get the signal to constrict when the light is shone at one eye. But then if we contrast that with our other one that we've just seen, where the optic nerve's not working, you end up with the complete afferent defect. So I hope that's useful.